Now this illustration illustrates taps not over 10 foot long in accordance with NEC 240.21, B as in boy, 1. Now notice in step 1, the 600 amp overcurrent device that we reviewed in the previous illustration is divided by 10. And that's naturally taking 1 dividing by 10, or not dividing by 10, but 110 times the overcurrent device. And it's just easier to say 10 into the overcurrent device. And you can see that the minimum tap is 60 amps. You'd say, well, I need a 40 amp tap. Then that overcurrent device would have to be 400 amp divided by 10, giving you 40 amps. So what we're saying in step 1 is the size of the overcurrent device that determines the minimum size of the tap divided by 10. Now, note 2, table 310.16, we're using a number 6 that's good for 65 amps. So naturally, we're larger than 60, so that's okay. Now, step 3 that you see, we're applying 240.21 B1 item 4. And notice 65 amps is greater than 60, so we're in full compliance up to now. Now, sizing the overcurrent device in step 4. 240.21 B1 1, 240.4B, and our table 240.6A, 65 amps used to be used, and you could round up to 70 amp. That's no longer permitted. You have to round down with this tap and fully protect the tap conductors. So basically then the size THW copper conductors is number 6, and the size of the overcurrent device should be 60 amps. That's the solution and the answer. Now note states another method which we do not recommend use, and the method is multiply the number 6 AWG copper conductor, THWN, 65 amps by 1,000. So 65 amps times 1,000 is 650. So the 600 amp overcurrent device is less than 650, but sometimes that confuses electricians, and they just rather take the overcurrent device, divide it by 10, and that's the minimum size tap that you see in step 1. So figure 9-22B illustrates to me the more complicated way or the easiest way to design taps not over 10 foot long in accordance with NEC 240.21 B as in boy 1.